here we go. We have section 4.4 and section 4.5 and 4.6 is kind of a summary, so I'm not going to do a whole lot with section 4.6 for us, but you will need to take a look at that, and we'll talk a little bit about it, but it's mainly just a summary of everything we've had up to this point, and as far as curve sketching. So we got to talk a little bit more, this thing called concavity. To get us started with this, concavity is an interesting graph. Let's see if I can come up with one for us. On your inspires, let's see what we can do here. I believe we had one, something similar to this, x to the third power minus 2x squared plus 5x. Now let's just stop with that. And if we graph, no, that's not what I wanted. Okay. Actually, we could use that one, but let's see if we can't get it to be a little more interesting here. I'm trying to remember what we had here. There we go. That's more like it. And I'm going to change the window just a little bit. Let's see if we can't get a window that might help us see the important pieces. Now, when I talk about the important pieces of a graph, do you know what we're talking about? What's interesting about a graph such as what we see on the screen? Good. Okay, you're right. I'm reading your minds, of course. You're right. We need to know, where it crosses the input axis. We need to know, where the dips and the valleys and the hills and the mountains and the increasing and decreasing and all that stuff. Those are what we would consider to be interesting pieces. So I'm going to capture that, and I'm just going to insert that so we can do some other stuff with it here. Okay. Without even a formal discussion about what is a, what is concavity, inflection points, and all of that, let's just take a look at this. If I show you right about here, if that's all you saw of the graph, how would you describe that portion? Give me all the descriptors you can. Good. It's increasing on this side. Very good. Okay, what else? It has a maximum. Okay, what else? It's decreasing on this side. Good. What else? Section 4.3. What did we talk about there? Okay, we have critical number. Critical number would be corresponding to what piece that's already here. The maximum, so there's a critical number, somewhere maybe about in here somewhere. We would say that input value is critical, okay? What other connection can we make to section 4.3 and 4.2? We talked about what? Yeah, look back in your notes. If you can't see it on the screen, look back in your notes. If we don't see where we've been, we often don't know where we're going. So, look back. Where have you been? What did we talk about? Becky, you look like you have an answer.
Well, I was thinking that it's concavity.
Yeah, we're not talking concavity in section 4.2 and 4.3 though. Okay, so let's look back. Okay, look back in section 4.2, 4.3. What did we talk about in those sections? Okay, okay, let's go to 4.3. What did we talk about in section 4.3? I know you were here. You had, you looked at the video, some of you. You sat in the class. I had the opportunity to instruct on that. What was the main idea of 4.3? Yeah. Connecting to what? We looked at increasing and decreasing, but we connected it to something we've been talking about all semester. Derivatives, yeah. So what about the derivative? How does that relate to anything we see on the screen? Nancy? Oh, Nash, what is it?
The derivative is at 0.
For where?
On the maximum.
Okay, so we know that the first derivative of this function is 0, right there. What else do we know?
And the function is increasing the first derivative.
Okay, so this piece right here, the first derivative is positive. What else? Waiting for one more piece of information. Yes, James. The derivative is negative, corresponding to the decreasing. Okay, now that's where we've been. We found then, and maybe I don't think we really put it in these terms, but in section 4.3, we were considering where the function changes direction. Where the function changes direction. And that's related to the sign of the first derivative. So the function changes direction. It stops increasing, changes direction, starts to decrease. When we can locate the point where the function changes direction, we have found an extrema. So the first derivative is connected to changing direction. Now, Becca, you're ahead. You're looking at section 4.4, which is good. And so share it with us now again, what you're saying. So at this portion, if you see this, yes, we would look at this as being concave down. So this is the new bit of information then for section 4.4. So not only is all of this true, but we can also say that from here to about here, the curve is concave down. Now we're going to have another bit of information that may seem in conflict. When I think of concave down, I think of that as a negative idea. You can use this or not, but one way that I've always tried to remember this and help students remember it is coffee cup down. To remind myself, that's a negative. Now, where's the negative come in? You'll see in just a minute. Okay? But if you have a coffee cup and it's filled with coffee and it's upside down, it's a negative idea. Okay, so that's the connection I'm making. Now, the positive connection to that is the fact that when it's concave down, you have a maximum. And we often think of maximum as a positive connotated idea. So the maximum, the positive idea, goes with the fact that it's concave down, which is a negative. So where else do we see and how do we figure this out? That it's concave down and that this portion. Okay, we're going to get to that in just a minute. Okay, so what I want to do, let's see. I'm going to open this up to about here. It's the same function, right? Same function. But now it looks as if we would say this is concave up. We can go through all the other stuff again. You know, we've got a minimum. We might want to put that in here. We have a minimum at this point. We know that up here somewhere we would then have a critical number, and that's where the first derivative, again, is 0. This side is decreasing. This side is increasing. All the stuff we talked about with first derivative is still valid. But now when I look at this, I would say that this portion of the graph seems to be concave up. And again, if you use my analogy, it'd be coffee cup up. Okay, positive idea. Like to have the coffee cup filled with coffee and right side up, you know, coffee cup up. But minimum is that negative idea that we also associate with this. So we've got a positive negative idea going on here. But we have then, it's concave up here, and concave down here. So this function, the very same function, is changing concavity. At some point in here, we have a change of concavity. Now, this is what we're talking about in section 4.4. You know, this is where the function changes concavity. We'd like to know, what is that point? What is that point where the function stops being coffee cup down, starts being coffee cup up? Concave down, concave up. Let me tell you that there are some books that instead of talking about concavity, talk about convexity. And so they would say that where we say this is concave down, they would say it's convex up. Okay? I don't really have another analogy to go with that, and our book thankfully uses the concavity idea instead of the convexity idea. So just want to let you know there are some books that use the other way of describing this. So we have this curve with this function. We know that it changes direction at a critical number of the function, meaning where the first derivative is 0. But then we throw in this thing of changing concavity. And the point where we change concavity is known as an inflection point. An inflection point. We call that the point where concavity changes. Now, what do we call the point where the direction changes? Well, we also end up with some critical numbers with concavity, with the inflection points. So give me another one. You're absolutely correct. It's a critical number of the function, but what's another way that we describe where the direction changes? We call it an extrema. Yeah, we call it an extrema. Now, we needed to find out, you know, is it a maximum or minimum? But where the function changes direction, we have an extrema. Now, if the function doesn't change doesn't change direction, we don't have an extrema, but we could still have the first derivative to be 0. And so we're going to take a look at what happens at those points. Okay, so at the extrema, where the direction changes, is where the first derivative is 0. Some of you know the answer to my next question. Those of you who don't, take a guess. How are we going to determine inflection points? First derivative 0, determine extrema. Second derivative 0 may, I have to say that, may determine inflection points. Okay? There's always the chance that it doesn't behave like we expect to. But where the second derivative is 0, that is where the change of concavity may occur. Okay? Now, that's just an illustration of this. Let's go back and look at this formally and get all the other notes in. Concavity in the second derivative test, so we are going to be using the second derivative. Let the function let f be a function whose second derivative exists on an open interval. So now we're talking not about a first derivative being defined, but now a second derivative. If You know, notice we don't go back and say the function is continuous on the closed interval and